So hello everyone. I hope you have done chapter 1, all the videos you have observed and you attended all the sessions as per the plan that we had formulated. So 3 days, Friday, Saturday, Sunday, we had gone through the videos. I suppose I had posted in the respective groups. So again, I repeat, please do watch the videos. It's important that you watch the videos and try out each and every question. I'm also sending you the solutions in the format of a PDF. Please do go through that. So I hope that chapter 1 has been complete, because it's very important that as I keep posting, you need to do this. So chapter 2 we are starting, that is polynomials, and in polynomials we are going to first discuss what you did in class 9, and then gradually we are going to come to what is class 10. So in polynomials, what is important for us to understand is that what are polynomials? We need to understand what are polynomials exactly. So polynomials are algebraic expressions in which the power of the variable is a positive integer, right? It's very important to understand this. What is a polynomial? So if you are having x square plus x cube plus x square plus 5, this is a polynomial. Whereas if I have x to the power half plus 3, this is not a polynomial, because the power is not a positive integer. It's not a whole number, it's a fraction. So remember, you cannot have a fractional power on the variable. On the power of 3, you can have anything. You can even have negative numbers, or you can have power as 1 by 3 or 1 by 4 fraction. It doesn't matter. But what is important to identify a polynomial is that the power of the variable in the polynomial should be a whole number. That means it can be 1 to infinity. It cannot be fractions, it cannot be in decimals. So when we have 3 root x plus 5, this is not a polynomial, for the simple reason that when you are having any variable in the root, the meaning is that the power of x is 1 by 2. So this is what we have done in class 9, identification of polynomials. You remember that. Now, depending on the power of x, we need to understand that if the power of highest power, okay, the highest power is 1, then that is called a linear polynomial. Okay, the word linear means the highest power, right, is 1. And if you are having the highest power as 2, then that is called a quadratic. Okay, that is called a quadratic polynomial. And if the highest power is 3, that is called a cubic polynomial. So this is what you have done in class 9, linear, quadratic, and cubic. The highest power has to be seen, and accordingly we can very easily classify it as linear, quadratic, or cubic. Then what you also did was a monomial, binomial, and trinomial. I hope you remember that also. Monomial was a single term. Binomial were 2 terms, of course 2 unlike terms, and trinomial were 3 unlike terms. So if you have any problem in understanding linear, quadratic, cubic, monomial, binomial, trinomial, I will request you to first go through your class 9. Although it is not used here, but see, the MCQ comes, so therefore it is important that you know, because they can test you on these concepts as well. Okay, so we straight away now move on to polynomials, the chapter that we are supposed to do in class 10, right? So in chapter 2 polynomials, the first exercise, if you see, is based on a graph. The graph, it need not to be made. The graphs are already given to us. The graphs are already given to us. So if you look at this graph, the graph of y is equal to px. Y is equal to px. That means this is a polynomial in x. So it could be anything. And the question is, find the number of zeros of the polynomial in x in each case. Find the number of zeros in each case. So please note down, the number of zeros will always be equal to the number of times this graph is intersecting the x-axis. Okay, I repeat, the number of zeros is equal to the number of times the graph is intersecting the x-axis. So how many times is the graph intersecting here at the x-axis? That has to be seen. It is not intersecting the x-axis at all. So I will say this doesn't have any zeros. This doesn't have any zeros. Look at the next one. This graph is intersecting the x-axis at how many points? At 1 point. So I can say the number of zeros is 1 in this case. If you look at the next one, 1, 2, 3, the number of intersection points are 3 on the x-axis. So we can say the number of zeros is 3, and similarly here the number of zeros is 2. So if the polynomial is in x, what needs to be seen is that how many times is it intersecting the x-axis. I suppose this is clear. Okay, another thing that we have to note is, okay, let me complete this, then I will tell you. So how many zeros here? 1, 2, 3, 4. 4 intersection points on the x-axis. Therefore, I can say number of zeros on the x-axis is 4. So here 1, 2, 3. Even if it is touching, that is considered as a 0. So 1, 2, 3. Number of zeros is 3. So this is how we find the number of zeros. So this exercise is pretty simple. You will be able to complete all this in about 10 minutes or 5 minutes. But also we need to understand, suppose we are having a graph like this. This is your x-axis and this is your y-axis. And let's say the coordinates are given to me. And I know that it is intersecting at how many points? 1, 2, and 3. So I mean, according to the question, the number of zeros will be 3. So we have 3 zeros. But what are these zeros? What are the zeros? The zeros are the intersection points itself. So intersection point is -1. Intersection point here is 0. And intersection point here is 2. So we have 3 zeros. What are the 3 zeros? -1 and -1, 0, and 2. So this is how we find the zeros in case it is asked. Although it's not mentioned in the textbook that you have to find the actual zeros. They are asking you to find the number of zeros. The number of zeros is 3. And the value of these zeros is -1 and 0 and 2. So please make a note of this. In case it is asked, you will be prepared to answer such kind of questions. So there's only one question there. So that's over. Now we go to exercise 2.2. So in 2.2, the question is find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Okay, you have to find zeros and then you have to verify. Okay, so I'm taking this question, x square minus 2x minus 8. Okay, that's your first question, x square minus 2x minus 8. X square minus 2x minus 8. So this is factorized by splitting the middle term. I hope you remember that. You have to multiply the first number and the last number. That gives you your product. So product is x square into minus 8, that is minus 8x square. And when you add, you have to get the number at the center. Sum is minus 2x. So this is the first thing that you do. Multiply the first and last and write it as product. And the number at the center minus 2x, you're going to write it as the sum. Now we have to think of two numbers which on multiplying will give me -8 and on adding will give me -2. Okay, on multiplying I should get -8 and on adding I should get -2. So what are our two numbers? See, on multiplying 8, there is only two possibilities, that is 4 into 2 and 8 into 1. You cannot get a product of 8 anywhere else. Okay, addition of -2, there are infinite possibilities. But when you multiply two numbers, 8, there is only one possibility, 4, 2 and 8, 1. That means I have to select one of these combinations. Now, when you add this, you should get -2. When you add this, you should get -2. So if I try this, my factors are going to be -4x and positive 2x, isn't it? It will be -4x and plus 2x. This also you have done in class 9. So when you add this -4x plus 2x, you're getting -2x. And when you multiply -4 and positive 2, you get -8. So that's how we find the factors. So this is called splitting the middle term. So the first and last term will remain as it is. The middle term I am splitting as -4x and plus 2x. Middle term I am splitting as -4 and plus 2. So take common in this, we get x common, x minus 4, plus 2 common, x minus 4. And if your factorization is correct, please remember these brackets will come same. So you're going to combine this, we get x minus 4, and this you are going to combine, you get x plus 2. Okay, so these are your factors of this polynomial that was given to us. Now we have to find the zeros. Now what are the zeros of a polynomial? How many zeros will it have? First of all, the power of x here is 2. The highest power is 2. So just now we discussed that the highest power is 2 means it's a quadratic polynomial. Now every quadratic polynomial, that is when the highest power is 2, will have two zeros always. Okay, always two zeros, and these zeros are represented by the Greek alphabets alpha and beta. Okay, so this is alpha and this is beta, always represented by alpha beta. If there are three zeros, that is cubic polynomial, it is represented by gamma. Okay, alpha, beta, gamma. And if there is a fourth zero, that is represented by delta. Okay, these are all Greek alphabet. So at the moment, we are not discussing gamma and delta. We are discussing alpha, beta, the two zeros. So how do you get those zeros? The first zero, x minus 4, we are going to equate this to 0 and we get the value of x as 4. And here also I'm going to equate this to 0. So x is equal to negative 2. So alpha is 4 and beta is negative 2. Okay. Alpha is 4 and beta is minus 2, or alpha is minus 2 and beta is 4. The order doesn't matter. So these are our two zeros. So we've got the first part, how to get the zeros. Now comes the verification. So what happens in the verification? There are two verification formulas. First is alpha plus beta is minus b by a. Okay, this is the first verification formula. Please note, alpha plus beta is minus b by a. Now, what is this alpha and beta? That we have already discussed. But what is this a and b? A, B, C are the coefficients of your polynomial of x square, x and constant term. So what is A? A is the coefficient of x square. So what is the number with x square? Okay. So ax square plus bx plus c, that's your general form, for example, for a quadratic polynomial. So a is the number with x square. So what is the number here? Nothing is written, means a is 1. Okay, so your a value here is 1. And x, the coefficient of x is b. So what is the number with b? That is negative 2. Please make sure that your signs are also taken. Okay, don't just take the numerical value, with the magnitude you have to take. So the value of b is minus 2 and c is the constant without the x square or the x, no variable along with it. So c value again with the sign has to be taken minus 8. Okay, so alpha plus beta is minus b by a is your first verification formula. So if I start with solving the LHS, so alpha plus beta, so we get 4 minus 2, so you should get 2. And when you solve the RHS, what happens? Minus b by a, so minus of what is b? Negative 2 upon a value is 1. I'm substituting the value of ABC here. So I'm at the moment it is minus b by a. So minus of minus 2, we get 2 upon 1, which is equal to 2. So these two are coming equal. So which means that I have verified this, my answers are correct. Then also there is a second verification formula. So you need to do both, okay, not one. Both verification has to be done. So alpha beta is c by a. So first I'm going to solve the left side. Alpha and beta has to be multiplied. 4 into minus 2, you get negative 8. And the RHS is c by a. So c by a means minus 8 upon 1. So negative 8. So LHS is equal to RHS. So I've got this. Both LHS equal to RHS. Therefore, I can say alpha is 4 and beta is minus 2 is the correct zeros. So if it is a 2-mark question, probably they will ask you only to find zeros. If it is, let's say, 3 or 5-mark question even, then they may ask you first find out the zeros and then do the verification. So you need to know how to verify, how to get the answers, and please remember both of them has to be done, not one. Okay, right? So 4s square minus 4s plus 1, same technique. I can do by splitting the middle term. Minus 2s and minus 2s are the factors. Okay. And I can also use identity. This is in the form of a square minus 2ab plus b square. So this becomes a minus b whole square. Okay. So that is the method that they have used, a minus b whole square. So you get 2s minus 1 whole square. So s value will become half and half. So twice. Okay, because whole square, when I say 2s minus 1 into 2s minus 1, so I'm going to get s is equal to half and s is equal to half 2 times. So your alpha and beta both are coming half. That is quite possible. You can get equal also, no problem, but you should get 2. That's important. Okay, so once you get alpha beta, then this is your ABC and then you can verify. Now the third part, 6x squared minus 3 minus 7x. Now see, this is little tricky. 6x squared minus 3 minus 7x. See, most of the students, they will start doing this. So before doing this, you should put it in standard form. Now, what is the meaning of standard form? First, the x square term should come, then the x term should come, then negative 3 should come. After this, the procedure is same. But don't start doing with this. This is to be done. Now the product, you will multiply the first and the last, that is minus 18x square. And the number at the center is minus 7x, right? So you have to think of two numbers which on multiplying will give me 18, on adding will give me 7. So 18 combinations could be 6 into 3, 9 into 2, or 18 into 1. So these are the combinations that I have. Now when I take 6 and 3 combination, I'm not going to get 7. But when I take 9 and 2 combination, I'm going to get 7. So my factors will be 9 and 2. So minus 9 and plus 2, because when I add, I have to get negative 7, right? So this is negative 7. Yes. So first term and last term as it is, as I told you before, here I'm going to use the factors, splitting the middle term minus 9x and plus 2x. What is common here? 3x. So we get 2x minus 3 plus 1 common, 2x minus 3. Right? These two brackets are same. That means my factorization is correct. Now I'm going to combine this. We get 2x minus 3. This is common. And what is left here? 3x plus 1. So from here, I'm going to equate this to 0. So value of x is 3 by 2. So that's alpha. And 3x plus 1 is 0. So 3x is negative 1. X is minus 1 by 3. So this is beta. So we've got alpha and beta. Now once you get alpha and beta, the verification formula is alpha plus beta is minus b by a. And alpha beta is c by a. You can verify this. Now, please remember, when you take ABC, do not take ABC from here. Take ABC from here. This is the standard form. So, A is 6. B is not negative 3. B is the coefficient of X. Remember, B is, don't write it here. Many children I have seen writing ABC from the original question. No. You have to write ABC from the standard form, because what is the meaning of B? B is the coefficient of X. B is the coefficient of X. Please note this. So whatever is with x, so that is negative 7. And c is without any variable, that is your constant. So c is minus 3. Again repeating that the signs should be there. Otherwise you will not get the verification. Okay. So you can do the verification very easily and get LHS equal to RHS in both cases. Right. Then we go to the fourth part, 4u square plus 8u. Now look at this, 4u square plus 8u. 4u square plus 8u. Now there is no third term. So some students get confused what has to be done. We can't do this by splitting the middle term. All you need to do is take common. So what is common? 4u is common in this. So when you take 4u common, what is left here? U plus, how many times 4 goes in 8? 2. U is already out. So you get this, right? So 4u is 0 and u plus 2 is 0, equated to 0. So u is 0 by 4 and 0 by anything is 0. And here we get negative 2. So alpha is 0 and beta is minus 2, or vice versa. So we get alpha and beta. Now what is ABC? A is 4, B is 8. And please remember there is no constant term here. So C is 0. And now we can do the verification. Alpha plus beta is minus B by A and alpha beta is C by A. Right? Both the verification we can do very easily. Okay, so if I'm doing the LHS, alpha plus beta, I'm going to get 0 minus 2, that's negative 2. RHS is minus b by a, that is minus 8 by 4. Again, I'm going to get negative 2. So both are equal. Similarly, LHS alpha into beta, that is your 0 into negative 2. So that's 0. And RHS, if I calculate, that is c by a, that is 0 by 4, that is also 0. So LHS equal to RHS, hence verified. So this is the method. So you need to practice these questions. I'm sure you will be able to do it very easily once you understand the technique. Okay, t square minus 15. Now this is another tricky question. T square minus 15. Again, it's not an identity which is directly expressed as we did in the previous question. But yes, if you look at 15, it's not a perfect square, but we can write it as root 15 whole square, and then it becomes an identity. Okay, so probably many of you thought it's not an identity because it's not directly visible. But if it is t square minus 16, I know it is t square minus 4 square. A square minus b square is a plus b a minus b. But no worries, even if you are having a number, please remember that t square minus 15 This also can be expressed in terms of a square minus b square. What you need to do is t square minus, this can be written as root 15 whole square. Okay, 15 can be written as root 15 whole square, because when you multiply two numbers with the same number in the roots, the root goes away, because root 2 into root 2 is 4, root 4, and root 4 is 2. So using this, I can say that 15 is the root 15 whole square, the square of root 15, right? So this is an identity which you have done. A square minus b square is a plus b, a minus b. So this can be written as t plus root 15 and t minus root 15. I'm going to equate it to 0. So alpha value will come negative root 15 and beta value, I'll take this, equate to 0. So negative root 15 will go to the other side and you will get positive root 15. So alpha beta values you are going to get. Now what is your ABC in this? A will be 1 because the coefficient of t square is 1. And what is the value of b? Please remember, this is not b, this is not b, because there is no t term here. So b value is 0. And this is actually your constant. C is negative 50. Okay. Identification of ABC is very important, because otherwise your verification goes wrong and you will think that your answers are wrong. Your answers may be correct, but if your identification of ABC is not incorrect, then also verification fails. So A is 1 because the coefficient of t square is 1. There is no t term, so it is actually 0t. So the coefficient of t is 0. So B is 0 and this is C. And then you can verify this. Right. Okay. Then 3x square minus x minus 4, direct question. You can split the middle term. You will get factors minus 4 and plus 3. And you will be able to verify also. Right. So that is the end of question 1. I'm sure you've understood how to do it. Please do try each and every question. It's important that you do this, because every day we are doing just one exercise, and that one exercise has to be done thoroughly. Then only at the end you will be able to say that I have finished my NCERT thoroughly. Okay, question 2. Find a quadratic polynomial with the given numbers as the sum and product. So this is the sum and this is the product. We need to form an equation. Okay, we need to form an equation. So there are two methods to do it. The easiest method is, if the sum and product are given, you can use this formula x square minus sum x plus product. This is the formula x square minus sum x plus product. So if you are given the sum as 1 by 4 and the product is given as negative 1, okay, sum is given, this is the sum and product respectively, means this is the sum and this is product. So sum and product is given. So sum is 1 by 4, so I'm going to substitute 1 by 4. And what is the product? The product is negative 1. Okay, so this is what the sum and product. So every question, this is the sum and this is the product. Okay, so what will I do? This is the equation that I'm getting here, x square minus x by 4 minus 1. Now, normally what happens in a polynomial, we get rid of the denominator. So what I can do is multiply each term with 4. Multiply each term by 4. So when I multiply this, I'm going to get 4x square, x by 4 into 4 and 1 into 4. So this 4 is getting cancelled and we get 4x square minus x minus 4. So here the question was, find a quadratic polynomial. Find a quadratic polynomial is one polynomial. So this is 1. But there are infinite polynomials which can have sum 1 by 4 and product negative 1. So in some books you will find this k. Okay, you will find this letter k. So that shows that there are many possibilities. Any real number, k is any real number. So we got this equation 4x square minus x minus 4. Now, if you check at the back of the NCERT, they have given only this answer 4x square minus x minus 4, because the question was find a quadratic polynomial. So one polynomial. So this is one polynomial, right? But if you multiply this by 2 or 3 or 4 or 10, any number, any real number, then also that will be a valid answer. So therefore, if they are asking you find quadratic polynomials, then probably you can write down k times 4x square minus x minus 4, where k is any real number. So all these questions are of the same type, sum and product, sum and product, sum and product, everything is given, so you can find out. So let me also show one more. Let's say 0 and root 5, the third one. Okay, this is question 2, third one. The sum is given as 0 and the product is root 5. Okay, so first I'm going to write the formula x square minus sum x plus product. So x square minus, instead of sum I'll put 0 and the product is root 5. 0 into anything is 0, so I'm going to get x square plus root 5. Simple. So this is one polynomial that I'm going to get x square plus root 5. But as I discussed, the answers are going to match as per the NCERT. You will get x square plus root 5. But as I told you, if you put k, that is not wrong, because k is any real number. Any number multiplied by this polynomial, the answer is going to still remain the same. So in your final answer, if one polynomial is asked, x square plus root 5 is correct. And if you want more polynomials, you can multiply this by any number where k is any real number. You just do that. So you can write the answer as k times x square plus root 5, right? So that's how we do these questions. Another precaution that you have to do is that sometimes they will give you alpha and beta. So alpha is 2 and beta is 3. Find a quadratic polynomial. So most of the people know this x square minus sum x plus product, the formula that I have given just now. And what they are going to do, they're going to write this as x square minus 2x plus 3. This is absolutely wrong, because this is not the sum and product. These are the zeros. Okay. So what is the meaning of sum? Sum of zeros means you will have to add these two. So x square minus, its sum is not, this is sum and product was given to us. That's why we applied this. But in the exam, this is a precaution you have to take. If alpha and beta are given, please do take out the sum of that. So 2 plus 3, you have to write here 5. Okay. And product, what is the meaning of product? You have to multiply 2 and 3. Okay. Here we are adding 2 and 3. The zeros have to be added. So x square minus 5x plus 6, you're going to get this. So this is wrong. This is correct. Okay. So please make sure whether sum and product is given or alpha and beta is given. Accordingly, you'll have to apply this. So when you're using this x square minus, if alpha and beta is given, better to write down this x square minus. Don't write sum, because directly you may substitute these as in the NCERT. It is alpha plus beta into x plus alpha beta. Okay. X square minus alpha plus beta into x plus alpha beta. So that's how we come to the answers of question 2, or these you can do by the same method. So these are the two questions, very easy questions. Now the good news is that 2.3, the division algorithm, which was actually the tough part, has been cancelled. Division of polynomials is cancelled. So 2.3 is not there at all. So this you can cancel.